Hello, let us look at the maximum and minimum problems together here. For the first question, for what value of k will x plus k over x have a relative maximum? Now, since they're talking about relative maximum, what we have to do is we need to find the critical value. Now, then in this case, since they told us that we are looking at x has to be equal to -2, what we end up doing is we have to take the derivative of this one and set it equal to 0. But the thing is, when x equals -2, this derivative has to be equal to 0. So we'll see what happens. When you take the derivative of this, we end up getting 1 minus k over x squared. I just simply use the power rule here. Has to be equal to 0. But the thing is, x has to be -2, so this becomes 1 minus k over -2 squared is equal to 0. This tells us that then, yes, 1 minus k over 4 has to be equal to 0. Then for what value of k will this expression be equal to 0, or equation to be equal to 0? That's right. K has to be equal to 4. So I guess we get choice D as our answer. How about the second question here? The point on the curve, right over here, that is nearest to this point. Now, then nearest simply means the minimum, and then also implies the distance. Distance has to be the minimum. Then let us try to find the distance formula here. Then yes, distance will be equal to square root of x squared, or should I say x minus 0 squared, plus y minus negative 1/2. So I'm going to say plus 1/2 squared. This will be the distance formula. But the thing is, instead of using the radical, because many of us don't like the radical portion right over here, another way for us to write this one would have been something like this. D squared would have been equal to here x squared plus y plus 1/2 square. But notice that here x squared is equal to negative. This tells us that x squared is equal to -2y. Then putting this one in that location over here, d squared now can be written as -2y, and then here becomes plus y squared plus y plus 1/4. Now, so we can simplify this one further, but if you have to take the derivative, we know that this one and then this one becomes -y, right? So if you have to take the derivative, then this becomes 2d d prime is equal to 2y coming from y squared. Now minus 1 plus 0. That's what we end up getting. But this one has to be equal to 0, because that's when we're going to have a critical value. Then what is y equal to? Yes, y is equal to 1/2. And that's exactly what they're looking for. Choice A becomes our answer. Number 3. A point moves on the x-axis in such a way that its velocity is given in this way. Now we're looking for v attain its maximum. Simply, we're looking for, given that v is the function, and to find its maximum, what we have to do is find the derivative and set it equal to 0. So let's try to look into this one. Since v is equal to ln of t over t, what we're going to do is this. What is v prime? I understand this can be expressed as a if you wanted to. And we can use the product rule here. Then t squared, that's the bottom one. And derivative of the top becomes 1 over t times t minus ln of t times derivative of the bottom, which is simply 1. Now this one has to be equal to 0. Now, then this becomes 1 minus ln of t over t squared has to be equal to 0. How can we have that? That's obviously, when the fraction is equal to 0, the numerator has to be equal to 0. So we get 1 minus ln of t has to be equal to 0. That means 1 is equal to ln of t. What is t equal to then? That's right. This implies that t has to be equal to e. So choice C must be our answer. Alright. Now let's look at number 4 here. Once again, we are looking for relative maximum. Then we're gonna first find the derivative and set it equal to 0. So when you find the derivative here, f prime, f prime is equal to 15 x to the 4th m minus 15 x squared. Now, to set this one equal to 0, what we're going to be doing is, we notice that 15 x squared is the common factor, then we have x squared minus 1. This implies that 15x squared and x plus 1 and x minus 1 can be another way for us to describe this one through factoring. Then we realize that x can be equal to 0 here and negative 1 from the second one and 1 from the third one. So these are the three critical values. Notice that here x squared, because of square, this actually 0 is the double root, then you will realize that about the double root, signs will not change. So you can safely assume that 0 will not be relative maximum, nor relative minimum either. But we'll try to see what we can do with it first. So here we have negative 1, 0, 1. Now, then we have to plug in the values into the first derivative to see if any interval gets us the positive or negative first derivative. So if I have to start with a value below negative 1, such as negative 2, then notice that this will be negative 2 to the 4th power. So let's look at it. What if x equals negative 2? Then we get 15 x squared. I'm looking at the first derivative, x plus 1 and x minus 1. That's another way for us to describe the first derivative here, if you remember. Then plug in negative 2, this will always be positive. This one is negative, this one is negative. So therefore, we know that sign here becomes positive. Then you can safely assume that because negative 1 was the single root from here, this middle factor, then next sign would have been negative. But 0 was a double root, so its sign will stay, and then the last one will become positive. And we are looking for maximum. Maximum happens when we are looking at positive to negative first derivative, which is at when x equals negative 1, which is choice A becomes the answer. All right, let's look at the next question. Number 5. What is the area of the largest rectangle that can be inscribed in this ellipse? Now, if you want to just look at this one a little bit carefully and visualize what kind of ellipse you will be getting, you can divide by 36 and all throughout, then we'll get x squared over 9 plus y squared over 4 equals 1. Now, then simply put x and y value would have been 3 and negative 3. And then, x values will be 3 and negative 3, y values will be 2 and negative 2. So we'll end up having an ellipse that looks something like this. Within that, we are looking for some sort of rectangle. Now notice that rectangle, that means here the base becomes 2x because each side will be equal to x and x, basically. While y value will go up and down, therefore it's going to be 2y, or absolute value of 2y, however we look at it, given that the point here is x comma y. Now, then, basically what we're looking for is, we're looking for largest area. Then we need to find the area formula. Area is equal to 2x times 2y, which will be equal to 4xy. But we need to take the derivative and set it equal to 0. Now, then let's try to express everything in terms of, let us say, y. How about that? Then this one becomes y squared will be equal to 1 minus x squared over 9, but we have to multiply that by 4. In other words, we get 4, 1 minus x squared over 9, but that's y squared, so if you have to get y, then all we have to do is take the square root of it. Then this becomes simply 2 square root of 1 minus x squared over 9. That's what we end up getting. Alright, then I can rewrite this one as this way. 4x times 2 times square root of 1 minus x squared over 9. Now if you take the derivative, a prime, then let's see what happens. Derivative of 4x becomes simply 4 times 2 times square root of 1 minus x squared over 9. And then plus 4x is there. Derivative of this expression, 1/2 comes out and then cancels out with 2, so simply becomes 1. And then we get 1 minus x squared over 9 to the negative 1/2 power. And then we got to multiply that by derivative of inside, which is negative 2x over 9. Now, then if you have to multiply this factor so that we could have the common denominator, then we would have gotten something like this. Here, denominator would have been, and then I'm going to just have 1 minus x squared over 9. Then on the left side simply becomes 8 times from 4 and 2, and this one has to be multiplied by itself, so we end up getting 1 minus x squared over 9. And then on the right side we end up getting minus 8 x squared over 9. That's basically what we end up getting. Now, so then if you have to simplify this one further, since we don't have much space, I'm going to bring this one to the top a little bit. Here we end up getting just the numerator has to be equal to 0. That means we get 8 minus, let me just change the color, 8 minus, we get 16 x squared over 9 has to be equal to 0. Then when we bring this one over, then we get x squared has to be equal to 72 over 16, which is equal to 9 over 2. So then x must be equal to 3 over square root of 2. Now, so then since x equals that way, then we should be able to figure out the y value. To find out the y value, you can put this x value back into this equation, or what we already found on the bottom. Once you calculate that, I believe you will get y value as square root of 2. So then our area, since we know the x and y value, by plugging them in, we will realize 4 times 3 over square root of 2 times square root of 2, which will lead us 12. So 12 would have been our answer. Alright, let's look at number 6 together. The derivative of f, this is a derivative of f already. How many points will have the will the graph of f have the relative maximum? Now notice that the critical values would have been here. 0 from the first one, 2 and negative 3. So negative 3 would have been here, and then 0 would have been here, and then 2 is around here. Notice 0 is, in fact, it's not the double root, but I guess fourth quadruple root. In other words, sign will not change about 0. So what we can do is, all we have to do is check up on the value less than negative 3 and then see what happens, how everything proceeds. So let us assume maybe x equals negative 4. Then this one, first one, it doesn't matter, it's going to be positive. Second one is negative. Third one is also negative. So therefore, what we end up getting is negative, negative becomes positive. That makes the next interval as negative. But since it doesn't change, it will be negative. And the last one will be what? Positive. How many points are we going to have relative maximum? Right over here at 1 point. Choice B becomes the answer. Alright, we'll continue in the second half very soon. See ya.